Okay, welcome back everyone to the C++ course. We are going to cover Chapter 2 today. Now right away you may notice a small or actually a pretty large difference in the audio. I've beefed up my microphone quite a bit. The good thing is, hopefully I sound quite a bit better. The maybe not so good thing is that this thing picks up everything. So I apologize in advance if you hear a dog wandering around, maybe even a yelp or two, maybe a little bit of noise going on outside my door. Again, apologies for that. These recordings aren't as polished as maybe they could be, but here we go. The main content will all be here for Chapter 2. I wanted to direct your attention, if I could, here to the dashboard. Our course here, hopefully you got the email. If you did not, they have changed our course number slightly. It is still CIS 161, but they've added this OR01 to the end of it. Honestly, I'm not sure why. Hopefully they've got everyone moved out of the old E100 course over here to the new OR01 course. So that is the one you should be using. That's where all the content is for this semester. I did add an announcement here. Our first one of the semester. Announcements are pretty much exactly what they say. If I forget anything, like in the video lectures or just kind of important things to mention, they will be added here. If I can figure out how to view the thing. Here we go. Couple notes that I didn't mention in the first video. You can call me Kevin if you're corresponding via email. I don't care for the formality of Mr. Grems. That's like my dad's name and stuff. Hopefully I'm not that old yet. So Kevin's fine. If you haven't noticed, I'm pretty informal, so first name basis is all good. When I'm grading your projects, this is a really important one. More important than what to call me, perhaps. If I'm going through and grading your project and it doesn't actually run, when I click run, or in other words, if there are compile errors, you're going to get 0 credit for that particular program. Not the whole assignment, just that particular program. I simply don't have the time and honestly the patience to go through and like figure out where all your little typing mistakes are and correct them and see if I can figure out what you really intended the program to do. There's just going to be no credit if I go to click run and it doesn't run. Finally, again, since this is an online course, you should be checking your Iowa Lakes email at least once a day, probably twice. When I communicate to the entire class as a whole, I'll either use the built-in email system within Canvas, or I'll do just this, which is making an announcement. Okay. Business out of the way, let us get into course content. So we are in Chapter 2. Finally, an introduction to C++. So we're actually going to be writing some programs in this course, or in this chapter. Pull up the old PowerPoint. Here's some of our objectives. We're going to take a look at the main parts of the C++ program. We're going to look at cout. We're going to look at the include directive, variables and assignments, literals, identifiers, some data types like integer, floating point, char, or char. I've heard it pronounced both ways. It's just char sounds kind of weird, so I always just say char, like character. Going to look at the built-in C++ string class. We'll take a look at the bool data type. We're going to look at how to determine the size of a data type. Now, this is something that actually is quite important in your C and C++ programming languages that really isn't as important in other languages, like dynamically typed languages such as JavaScript and Python. So this is something that's not unique to C++, but is really emphasized in the language, and we'll talk about why a little later. We're going to look at more on variable assignment and initialization. We'll take a look at what scope is, arithmetic operators, so how do you do math in C++, how do we comment our code, and a few notes on programming style, the overall general structure and flow of a C++ program. Now, as we're going through here, we'll stick pretty close to the PowerPoint, and occasionally it's going to direct us to our digital textbook or your physical textbook. I don't do a ton of the checkpoints. If there are some that I find are interesting, we'll deviate from the presentation and check out some of the sample questions in the checkpoints throughout the chapter. But for the most part, as we're going through, just to give you a little preview here, there are various hands-on activities and exercises within the chapters. I will direct you to the page number and then what listing the program we're going to be looking at is. Okay, the parts of a C++ program. Slide 1 of 2. So these are all the main parts of your basic Hello World, or I guess they call it Hello There program. We start off with a comment, which we're going to talk as much about comments as we need to a little later. There's not much to say. You probably know what comments are. In C++, they're marked by 2 forward slashes. This is one way to comment a single line. As you probably could have guessed, we can put whatever we want to after the 2 forward slashes. This is a way to document our code and leave reminders for us, as well as other people who may be viewing or editing our code, why we did what we did. When I was going through my introductory programming courses, the instructors had real strict requirements on how exactly you were supposed to comment your code and put the name of the program and your name and the date and the course and all this other stuff. I don't really get too particular on that. And when I was a student, I really didn't see too much of the point of comments. Now that I'm sort of out in the real world doing real big boy programming, big girl programming, the comments that I see in my code are extremely helpful. I work with a very, very large code base. We have 20 Visual Studio projects inside of our solution, and thousands and thousands, tens, probably 100,000 lines of code that we're working with. And a lot of those lines of code deal with complex calculations that I would have not a clue what they did had I not properly commented the code. So again, this is a single line comment. I will show you later on how you can do multi-line comments. Then we have something that's fairly common to most languages, if not all languages, and that's in C++, it's called a preprocessor directive. It begins with a pound sign or a hashtag, then the keyword include, followed by the library or package. You could call it many things as far as what you're actually including. And to draw parallels to other languages, basically to say that a programming language is very big. C++ is a large programming language. Java is a large language. Python is a large language. To have to include every single part of the language in every single program that we write would be extremely inefficient, and it would cause a crazy amount of bloat in our programs. It would make the files way too large. So instead what we do is we get the core language sort of out of the box, vanilla C++ or vanilla Java, vanilla Python. And then we use these preprocessor directives, or sometimes called include statements, to bring in other areas or other parts of the language that we think we might need as we're writing our code. This is the most common one you see in most of your intro to programming courses, IOStream, input, output, stream. When we include that package, when we use that include directive with IOStream, that basically allows us to use and do things like cout. There are many, many other includes that we're going to see throughout the semester, and I think even later today when we get into the string library. There's all kinds of cool stuff that's sort of packaged up and given to us by default in C++. So we'll include various things we needed. Using namespace std, using as a keyword, namespace is a keyword. STD is what's known as the standard namespace. And without getting into too much detail on that, you probably noticed in, I think last week we saw an example of this, where we saw something like this, std : cout, less than, or angle bracket, followed by the text we're printing out to the screen. Because we're including the standard namespace, you can see the code here matches. We include that standard namespace kind of as a shortcut, I guess, so that we can remove this requirement and just say cout. I will tell you, and if you don't remember this part of the lesson, that's okay. When you get out in the real world, or if you submit your programs to like online forums to get feedback or help from other programmers, if they see that you're using the standard namespace in your program or in your code, they're probably going to laugh at you, because you're getting a lot of stuff that you're probably not going to be using if you include the standard namespace. Standard namespace is huge. We're using like cout and cin, maybe a few others, but it is quite large. And there are ways to just include cout and cin of the standard namespace, so you don't have to bring in that whole namespace. I don't think we'll get into that this lesson, but just know that you can pick and choose little pieces of namespace to bring in if you like. Then we see the all familiar int main function. And I use the term function because main is a function. It has a data type that it's returning. And don't worry if that doesn't make sense. We're going to go through a whole chapter, probably several, on functions. Main is a special function in C++ because it is the program's entry point. When you run your program, it's going to look for int main, and that's where execution begins. It has open close parentheses. It accepts no arguments. It returns an integer. Beginning of function named main. Then we have open and closing curly brackets or curly braces. I use curly brackets, that term. And inside of those curly braces is all the code that is contained in the main function. Then we have a statement, the cout statement. Notice it ends in a semicolon. And finally, the return 0. The fact that main returns an integer means that we need to return something after this main function executes. Now, most programs that we see are going to return 0. That's just sort of like a dummy value to return from the main function. You could return other values though, like maybe you've decided that this program is running, and if it encounters an error, it's going to return -1. -1 is an integer, but you would know that when my program returns -1, that means there's a problem. If it returns +1, or some other number of your choosing, that means that it completed successfully. Totally up to you, as long as it returns an integer. Here's a table of the code we just saw, if a table suits you better than whatever this is. All right, let's check out the checkpoint on page 33. Yes, I use a mechanical keyboard. The key presses are just so satisfying. Okay, checkpoint. Following C++ program will not compile because the lines have been mixed up. Oh no. All right, so what's going on here? Hopefully it's pretty obvious based on the examples we just saw. So they've got int main. Okay, we know we need an int main function. We've got a backwards curly brace that needs to be flipped. That means that guy needs to be flipped. Above int main, we, I guess, would have the comment labeling our program, then our include. Inside of the curly braces, oh, we forgot the namespace. So we would have using namespace right after the include. And then our statements, cout and return 0, would go inside of the curly braces. I guess there's nothing preventing you from doing return 0 and then cout. But if you did that, the program would quit, program would exit, and then you would cout, which means you basically never see the cout. And I'm not going to on paper write a program that displays your name. Alrighty. Let's take a look at some special characters. So we've already seen that C++ has a variety of reserved keywords. We're going to see a more complete listing of those later, but there are also some special characters that we've, again, already seen. We have // // beginning of a comment, # or hashtag begins a preprocessor directive, or an include. There are other things that you can do with the pound sign or the preprocessor directive, but by and large, in this class, we're going to be using them for our include statements. We have opening and closing brackets. Encloses the file names used in includes. They're also used for, if you've had any programming courses before, they're also used for less than, greater than, less than equal to, greater than or equal to. We have open close parentheses, or I will call them parens, because I'm kind of lazy, used when naming a function and used in math, used for many, many things in programming. We've seen them in the context of a function. Open closing curly braces, or brackets, encloses a group of statements. Double quotes, open and close, encloses a string or a line of text. Doesn't have to be a line. It could be a single character. It could be an empty space. Could be no characters at all. This is a string too, an empty string. And yeah, sometimes it formats them strangely. There. If you do copy and paste code, which I gave my disclaimer on that in the last lesson, you do have to be careful with the double quotes. Sometimes with fonts, you'll copy some code from a website or from a PowerPoint or from a textbook, and it'll paste into your code editor or Visual Studio as like a different kind of double quote. So just be on the lookout for that. Semicolon ends a programming statement. You probably encountered the semicolon in some of your English classes. I still don't understand how it's used in English, but I do know and I'm very comfortable with using it in programming. It ends a programming statement. It's sort of like a period at the end of a sentence. Very important details. C++ is case sensitive. There are some languages that are case insensitive. They don't care whether you use an uppercase or lowercase character. But notice here, main, capital M, is not the same as lowercase m main. Notice that every opening curly brace must have a closing curly brace and vice versa. Thankfully, Visual Studio will help us with this. It will help us with our spelling too, and our case sensitivity. You may know if you've written any larger programs that you can end up with many, many nested curly braces, many nested parens, parens inside of parens instead of parens. Same thing with curly braces. The cool thing about Visual Studio and any decent text editor, including Notepad++, is that it will highlight, if you select an opening curly brace, it will highlight the corresponding closing curly brace. Quite helpful and good for our eyes, so we don't have to hunt down where the closing curly is for an opening. Almost to a hands-on here. Let's talk a little bit first about the cout object. It's not count, it's cout. Displays information on the computer screen. Use less than, or angle bracket. To send information to cout, you begin with the cout keyword, angle bracket, followed by your text enclosed in double quotes, followed by a semicolon. You can use the less than to send multiple items to cout like this. So I have one cout statement, followed by the angle brackets, followed by my text, followed by another set of angle brackets and more text. Doesn't really make much sense why I would do that in this example, but when we get into like variable substitution, if we want to display the contents of a variable inside a cout statement, we'll see that that will become pretty handy. Also, just because we use multiple couts doesn't mean we're going to get our text on a new line. This cout hello, this cout there will all be on a single line. There's nothing telling the standard output to go ahead and put there on its own line. We'll see how to do that, in fact, in the next slide here. Remember, computers only do what we tell them to do. If we didn't tell them to put a new line in our cout, it's not going to do it. However, there are two ways to force a new line. You can say cout hello there, your string of text, followed by angle bracket, followed by the keyword endl, stands for, as you probably guessed, end line, semicolon. If that doesn't suit your fancy, you can use a \n inside of the string itself. So you can see out hello there, \n. And we'll see this in our text editor in Visual Studio. It will actually highlight this \n. It's what's known as an escape sequence. It's just a sequence of characters that mean something special to C++. So these two lines actually do the same thing. Just kind of whatever fits your code the best, whatever you're more comfortable with using. I'm totally fine with if you're using Endel or new line like that. Mean the same thing. Notice that this is actually contained inside of the string, inside of the sets of double quotes. Finally, a hands-on. Okay. Let me take a drink. And let's write a little bit of code. Page 34. Squeaky chair. Okay. 2-2, right? Yes. 2-2. A simple C++ program. Now, probably more important than like actually writing out this program from scratch by hand, I'm going to show you again a little review here on how to best structure your projects and sample code for this class per chapter. So if I'm you listening to this video, starting chapter 2, I would go ahead and create a new project. I would do this same thing for every new chapter. Remember, we're looking at a C++ for our language, and we're going to select console app. This will actually, hint, hint, give us the exact program that we're looking for, hello world by default. So select that console app, next. And we're going to give this guy a project name and a solution name. Now, I wish they would put the solution name up top, because the solution name is like the high level, if you remember from last chapter, the high level sort of organization of the overall project. So solution name, I'm going to start with this. I'm going to call it chapter 2. And I want to be consistent, so I'm just going to try to remember where these are saved. Source, repos, chapter 1. Okay. Chapter 2, no spaces. I do not want to place solution and project in the same directory. And because these are examples, I'm going to use the convention for this project, this program. I'm going to call it EX2-2. Now for your assignments, you'll have probably a 2-2. So you'll need some way to kind of keep that separate from this example. So maybe your assignments are just 2-2, 2-3, 2-4, and your example programs throughout the chapters in the textbook, you'll put EX2-2. It's up to you how you want to sort of name them by convention. I'll go this route, though I'm sure there are other better alternatives. Here we are. Delete my boilerplate code. I'm actually going to delete everything in here just so we can get some experience hand coding something from scratch. Over here in my Solution Explorer, I've got my Chapter 2 solution, and then I have my example 2-2, my active project. Remember, it's highlighted in bold. And then finally down here is my actual source file, EX2-2. Don't worry about the header files. Don't worry about the resource files. We're going to be utilizing those in later chapters. They're a little bit more advanced techniques getting into object-oriented programming, which is a huge part of this course. So here's where I am, ex2-2.cpp right here. Now what I'm going to try to do, and you guys are at an advantage over me because you guys probably are working with 2 monitors. I'm dealing with one big one here, but that's okay. We'll just type this sample program by hand. Comment, a simple C++ program. And yes, I know it may seem pedantic. It may seem like, well, I'm just hand coding, like I'm copying and pasting without the Control-C, Control-V. But trust me, the act of programming, getting your fingers moving and getting used to typing these keys is very helpful. It just sort of gets you in that mode. It gets you used to using curly braces and semicolons and just kind of the general flow of writing a program. So there's my comment. Here's my include. It also gives you a chance to see IntelliSense in action, code completion. So I type a #, it's going to give me a list of possibilities. Include, tab, IOStream. Notice the syntax highlighting, using namespace std, semicolon. Then I begin my main function, starting with the keyword int, main, open, close, paren. Check this out. Let me do that again more slowly. Yes, change not saved, I know. I type an open paren. It immediately adds my closing paren. I type an open curly brace. It automatically gives me my closing curly brace. A couple words here about code formatting. The examples we've seen so far look like this. The open curly is on its own line. The closing curly is on its own line. All the statements go in between. Totally valid if you want to code this way, where the open curly is on the same line as the function name and the return type. Totally up to you what you want to do. I will tell you that the default settings inside of Visual Studio strongly prefer this method, at least when it comes to C#. I'm not exactly sure when it comes to C++ which way they're going to nudge us. But whatever way they nudge us, I'm just going to go ahead and flow with that. Cout. My string. Double quotes. It automatically added the closing double quote when I typed the opening. Programming is output great fun. Close that up a little bit here. Semicolon. Return 0. And if you noticed, before I typed in that return 0, I was getting an error. Maybe that's because it's because I didn't add the semicolon. I'm not going to add that return statement, and I'm going to run this program. It still ran. So it's kind of allowing us to fudge a little bit here. Because this is the main function, it's kind of giving us a pass when it comes to the return type. Best practice, though, is we said we're going to return an int out of this function. Let's return an int. When I returned that int, nothing really changes here in the console and the output. But if you look down here in the output tab in Visual Studio, it said has exited with code 0. So if that code means something to you, like we were talking earlier, maybe if your program has an issue and it, crashes or something, or it exits unsuccessfully, maybe you return a -1, and that means something to whoever is watching the output of this program. Cool. Okay. That's listing 2-2. We also want to tackle 2-3. So here's what I'm going to show you. We finished 2-2. Let's add another project. Add new project. Console app. We'll call it EX 2-3. And notice what it did here. It created that 2-3 project with a 2-3.cpp file. It is not the active project yet, so I'm going to right-click it, set as startup project. That way when I click the green arrow, that will execute by default. I'm going to collapse that. Now, it might seem like this is overkill. Like we're going to have one project for every example listing in the textbook. Yeah, I could see that argument. But just for the sake of keeping everything nice and separate and organized, I am going to create a separate project for each example. You guys don't have to do that. If you're following along on your own machine and you want to just keep going with the current project, like if you wanted to put a bunch of listings in 2-2, fine with me. However you want to keep yourself organized is fine. But I'm going to go with kind of the overkill mode and create a separate file for each. Okay, so again, plus we get that practice, a little bit of muscle memory here going. We're writing the various parts of our program. Standard namespace, int main. This time, they would like us to do cout is space great fun. To prove to you that we never told it to drop on a new line, so it is not dropping on a new line. And that's all for that. Hands-on 2-4 and 2-5. I actually have another instance of Visual Studio open here. I'm going to close that. New project, console app, next, EX 2-4. I think before we tackle chapter 3, I'm going to go into the project settings or Visual Studio settings and see about getting rid of all that boilerplate comments that it's adding. I'll let you know how to do that in the next video. But again, here we go. This is called an unruly printing program. We've included our IO stream. We're going to use the standard namespace. And here, we're going to see how to not output a bunch of text to the screen. So cout the following items were top sellers. Pull this over. During the month of June. Computer games, coffee, and aspirin. Is there a correlation? You tell me. Return 0. All right, so it kind of looks like it might be formatted okay because, I don't know, in our code editor, yeah, we got this on one line, this on another line, so on and so forth. But if we make this our startup project, run it, not so much. We have no new line characters, no escape sequences telling the program to output the text to a new line. So we need to tell it to do that. So everything's all kind of jumbled and mushed together. No spaces even either. If you notice, at the end of this line, okay, we've got June : double quote, no space between there, no space between the opening double quote and the C of computer games. So it's not going to put any space in there. If we check out the next listing, program 2-5, we'll see how to go ahead and add those spaces. Okay, let's see how we can clean up some of this text. So we'll add a new project to our solution. EX 2-5. And a well-adjusted printing program. Well-adjusted. All right, let's take a look. So we're being conscious of where we cout the following items were top sellers. followed by endl during the month of June. Endl. Notice it slightly highlights it in yellow, indicating that it is a keyword. Computer games, endl, coffee, endl, aspirin, endl, and we will return. I wonder what happens. Let's not return anything. Looks like it defaults to 0. So if we don't specify a return value, it's going to default it to 0 for us. Cool. Okay, so here's a good example of what went wrong. I still see the same output from the last example, and we can see a clue why that is. It's still running 2-4.exe. We want to run 2-5. So this won't be the last time that happens to me. I'm notorious for not activating my new project. Set it as a startup, run it again. Now let's see. Yeah, it still defaults to 0. But now we have a little bit more nicely formatted output to the standard console. Cool. Back to the PowerPoint. Here's 4. Oh, I lied. Page 36, we'll do one more. And let's see. Now, actually, I'm going to go ahead and take this same program, 2-5. I don't mind just reusing this one. It's so similar to the last one. We're just using a different kind of character sequence to get us to drop down to a new line. And you may find that you like this method better for the simple fact that you don't have to type as much. All I have to do is do \n, \n. You can see the syntax highlighting again. N. And if I run it, same output, slightly less code. We save ourselves some angle brackets and a keyword on each line. Excellent. Okay, so more on escape sequences, some more control over the output. We just saw an example of /n for new line. Causes the cursor to go to the next line for subsequent printing. If you would like a tab in your output, instead of sort of hard coding the 5 spaces or whatever the standard spacing for a tab is, I think it's 5 spaces, you can just do a /t, causes the cursor to skip over to the next tab stop. This is an old school one, /a. You guys should all try this on your own computers to see what, if anything, it does. Causes the computer to beep. And when it says beep, when I haven't used this since I took my intro to programming courses, but it used to use like the built-in alarm, the very primitive alarm that's built onto most computer motherboards. Backspace causes the cursor to back up, i.e. move left 1 position. Return causes the computer to go to the beginning of the current line, not the next line. Sort of interesting. If you would like to print, this is also a slight nuance in the language itself, since a backslash is part of the escape sequence itself. If you ever would like to or would need to print a backslash inside of a string, you simply use a double backslash. Same is true for single quote and double quote. So if you ever need to print one of those characters, either a single or a double quote inside of a sequence of text, just use /single or /double quote. So backslash, again, the nuance here, this is a backslash, this is a /. Remember to put the \n in double quotes. More on the include directive. We did talk about this a little bit earlier. Inserts the contents of another file into the program. It is a preprocessor directive, not part of the language, not seen by the compiler. It says another file. So what file are we inserting here? We don't really know. We don't really care. This is something that C++ provides to us. We're going to see later on in the semester we can actually include our own files into the program. So we're going to create programs that span multiple files. In your own programming and other courses, you've probably only dealt with programs that are a single file. In other words, just a single CPP file. But I mentioned this header files folder, resources, source files. There can be multiple tens or hundreds of external programs, separate programs inside of these folders that we can actually pull into our programs and use. Again, when we get into object-oriented programming, that'll make a little bit more sense. Make sure to note that there's no semicolon at the end of the include. Shifting gears here a little bit, variables and the assignment statement. All right, we talked a little bit about variables in chapter 1. So variable, if you remember, to review, is used to refer to a location memory where a value can be stored. Remember, computers address their memory using very cryptic looking hexadecimal values. To make that a little bit nicer, to make our lives as programmers easier, we can, instead of using hexadecimal addresses, make up our own sort of labels to refer to various parts of the computer's memory. We can then use the assignment statement to store a value at that address or at that location in memory. The value that's stored there can be changed. In other words, it can vary, hence the term variable. You must define the variable, indicate the name and type that it can hold before you can use it to store the variable. So when we say define the variable, we also mean declare. So declare or define kind of means the same thing. If a new value is stored in the variable, it replaces the old one. The previous value is overwritten and no longer can be retrieved. So here is an example of a variable. Here we have the integer data type. So integers, remember, are positive or negative whole numbers. -6, 0, 2, 457. All examples of integers. And we're creating a variable called age. This is a reserved C++ keyword. This is not. This is the name of the variable that we're using instead of referring to the location in memory. Later on, when we get into pointers, we're going to see how we can actually, instead of referring to this location in memory by the age sort of label, there's another little kind of trick we can do in C++ to see what the actual hexadecimal value is where age is stored. So this is the declaration, ends in a semicolon. This is the assignment. So we're sticking the value 17 in the age variable, semicolon. We can print the value of age to the standard output using cout. So instead of, so notice here we don't enclose this in double quotes. We just output the value of age. Then we're coming in here and reassigning age to 18 and printing it again. And you can see in the comments to the right here what you're going to see for your output. Important to note, we're replacing the old value with the new value. Hopefully that's obvious. If it's not, check out the example. Uses the equal sign for assignment. Has a single variable on the left and a value on the right. Textbooks like to make a big deal out of this, but I think it's self-explanatory. So we have variable name equals value. Copies the value on the right into the location in memory that's associated with the variable on the left. Also, if you notice back here, we never actually told it like where in the computer's memory we want to create this age variable. The compiler in the computer does that automatically for us. We don't care where it goes. All we care is that there's some place in the computer's memory that can store our wonderful age variable. Now, if you had an old computer that had maxed out memory, you would not be able to create an age variable because the computer doesn't have any more memory. Remember, we're referring to RAM, random access memory, when we talk about memory in this way. We're not referring to hard drive storage space, which can be in the terabytes. We're referring to random access memory, which can be in the, I guess these days, tens of gigabytes. All right, let's do a hands-on, page 39. Listing 2-7. And we're not going to do every single example in each chapter. I would say we'll do most of them, not all of them. So new console app, next EX2-7. Whoops. Comment include using namespace std. Int main, let's get rid of that. All right, let's play with some variables here. Let's declare an integer with the keyword int followed by the name of the integer we're declaring, called number, semicolon. Let's assign the value of 5, so number equals 5, and then print it. Cout the value of number. We could even do something like this. Practice with our escape sequences. The value of number is number endl. Okay, notice we've used 3 sets of angle brackets, or we're printing out this string. It's called a string literal, complete with escape sequences. We're outputting the value that's stored inside of the number variable, and then we're outputting a new line. Let's reassign number. Let's say number equals 7. Then we can do the value of number. Oops. You can see that escape sequences can get a little bit confusing. Endl. Return 0. Set as startup. Run it. The value of number is 5. The value of number is 7. So notice the double quotes here, just again to practice with our escape sequences. All right, literals. So a literal is a piece of data that is written directly to the source code of the program. So this would be an example of a character literal. We haven't seen the character data type or the char data type yet, but this is what it will look like. A single character enclosed in single quotes. Could be a space, could be nothing. That's a character literal. A string literal is enclosed in double quotes, a string of characters. 12 would be an example of an integer literal. Check this out though. The text 1, 2 inside of double quotes is also a string literal. The computer is going to treat this 12 as a piece of text and not an integer. So we wouldn't be able to add, for example, add a number to this version of 12. This one we could because it's an integer. This though is the string 12 or the text 12. 3.14, an example of a floating point literal. Hands-on, page 41. Listing 2-8. Alrighty. Int apples. Apples equals 20. On Sunday, we sold apples bushels of apples, period, \n, semi. Now we say apples equals 15. On Monday, we sold \n. You can actually even see the output here in the textbook itself. So it's a pretty similar example to the last one. So I wouldn't blame you if you don't want to type it all out line by line, but here is what it will output. On Sunday, we sold 20 bushels. On Monday, we sold 15. All right, a slide on identifiers and keywords. So programmer chosen names to represent parts of the program, such as variables. So we decide our variable names. There are rules, as we'll get into in a minute here, on what we can call our variables, what we can name them. The name should indicate the use of the identifier. There's a little bit of an art to creating your variable names. And yeah, you want to try to create a name that's more or less descriptive of what the variable is or what kind of data, what data it's going to hold. But that can get tricky if you have like too long of a name or not long enough. You wouldn't want to call a variable name A, for example. You cannot use C++ keywords as identifiers, so we couldn't call our variable int. We couldn't call it char or if or while or any of the other reserved C++ keywords. Our variable names must begin with alphabetic characters or an underscore. So you can start your variable name with an underscore. There's actually a sort of a convention in C++ programming why you would want to do that. That will come into play later in object-oriented programming, followed by any number of alphanumeric, numeric, or underscore characters. And the alphabetic characters can be upper or lowercase. There's like a keyword table, a reserved keyword table on page 43. For your reference, so this would be, under no circumstances would you be required to memorize this, and we're not going to use even most of these reserved keywords. But what you should take away from this table is you should not be using these names for your variable names. So don't use and, don't use auto, don't use default, delete, do, or any of these others. XOR. Multi-word variable names. So we've seen examples of single word variable names like number, age, and apple. But we know that a variable name should reflect its purpose. Descriptive variable names may include multiple words. So how do we actually do that? If you remember on the previous slides, the space character was not included in the list of valid characters that we can put in our identifiers. So we can't use a space if we have a multi-word variable name. So we have a couple conventions to use. So we can capitalize all words but the first letter and run the words together. So for example, quantity on order, that's a variable name. We've made the first letter lowercase. O in on is uppercase. O in order is uppercase. Total sales, lowercase first t, uppercase S for sales. One option for you, this is called lower camel case. There's also a variation of this called upper camel case where you just say, the heck with it, and capitalize all the first letters of each word. There's also something like this, use the underscore character as a word separator. This is a little more old school, I would say. You see this a lot in databases. So instead of using a space, the underscore kind of looks like a space, so treat it like one if I have a variable that's multiple words long. Use one convention consistently throughout a program. Basically pick one and stick with it. There are some common conventions when we get later on into our, again, object-oriented programming that I'll point out. But for the most part, if you want to pick a convention that you like and stick with it, I am just fine with that. Valid and invalid identifiers. So valid, total sales. Yep, definitely valid. Multiple words, sort of visually separated by the capitalization of the S on sales. Total underscore sales, yes, definitely valid, separated by the underscore. Total dot sales, nope, can't contain the period. The period is actually a reserved C++ operator, heavily used in object-oriented programming. Fourth quarter sales, nope, can't start with a digit, cannot start with a number 4. total $ sales, no, cannot contain the $. Descriptive though it may be. Okay, specifics of particular data types. So what is an integer data type? It's designed to hold whole numbers, non-decimal numbers. It can be signed or unsigned. What does signed or unsigned means? It means positive or negative. So if an integer is signed, that means it's negative. It has the sign out in front of it. If it's unsigned, it doesn't have the sign. It's a little confusing. It took me a while to figure this out too. But think of unsigned as just your regular numbers, like positive numbers. Signed, we have to use a negative sign if the number is signed or negative, so we call those signed. So signed or unsigned, available in different sizes, i.e. number of bytes. Remember, 8 bits to a byte. And there's a table we're going to look at here in a little bit of like how large these different data types can be. So you could have a short int, basically a small int, a regular int, a long int, or a long int. And long int was introduced in a sort of a modern version of C++, modern-ish. So signed versus unsigned, C++ allocates 1 bit for the sign of the number. So remember, 8 bits to a byte, one of those bits is going to be used for a sign bit. 1 is positive, 0 is negative, I think. If a variable in a program will not hold a negative value, you can declare it to be unsigned. So all the bits in the unsigned numbers are used for data. What this means is that an unsigned int can store larger values than a signed int because the unsigned int has all of its bits available for data, for the number itself, whereas a signed int has to use one of those bits to store the positive or negative, basically. A variable is signed unless the unsigned keyword is used at the definition. So by default, it is going to be signed. By default, you're going to be able to create your integers positive or negative. Let's take a look at a couple tables, 46 and 47. Here we go. Again, nothing that you'll need to memorize for any particular reason, but interestingly, this does show up from time to time in even real-world programs. If you have, for example, if you've declared something to be an unsigned short int, that means that that variable can store anywhere from the number 0 to the number 65,535. So I don't know, maybe you're storing your score variable. If you're a game program, you have a variable called score that you declare to be an unsigned short int. And the player is doing really well and racking up a high score, and they've just scored 65,535 points. The next point they score will fall outside of this range. And what's going to happen then is it's going to reset to 0 and start counting up again. You actually do see this error in real life. So while it's not necessary to like memorize these ranges, commit them to your memory, it is good to have kind of a general gist of how large or small these variables can be, because this does happen. That's called integer wraparound. On the 65,536th score, their score will become 0. And that could be painful. You can see here the unsigned long int uses 8 bytes, and it can go from 0 to whatever this number is. I don't know what number that is. Next page, 47. Let's see. Yeah, here's some samples. Short int month or short month. So these can be abbreviated. Instead of saying short int month, you can just say short month. Unsigned short int amount can be abbreviated as unsigned short amount. And these are good examples because, you know, a month, you're probably only going to store values of 0 to 11 or 1 to 12. Why do you need to use a whole integer? We just saw that the integer can store from negative values. So first of all, a month would never go negative and certainly wouldn't go up to whatever this number is, 2 billion. So why take up the extra space? Let's be efficient about it and used a short int to store a month. For a population, maybe we have an unsigned long int. It's unsigned because a population would never be negative. And it's long because it could be a large number. A couple tables there to keep for your reference. Easily found in a quick Google search, though. Let's do a hands-on, page 47. This guy here. This is listing 2-9. All right, get some practice here with some different data types. So int, checking, unsigned int miles, long diameter. Checking equals -20. Because it's a regular int, that means it's signed. So it can be positive or negative. Miles is unsigned, meaning it's only positive. We're assuming here that my number of miles would never be negative. 4276. As a side effect of that, I get to store larger values inside of miles because I don't have to use that 7th bit to store the sign of the number because we're assuming it's positive. Diameter equals some number. And we can print those to the screen. I'm just going to print the values. So we'll print checking like that. Miles. Like so. Start a project. Notice this, so it prints what we would expect. Notice that it does not add the commas for me in my numbers that require them. So you would have to do your own programming or use some external library or function to put those commas in and make them a little bit more presentable to the user. Remember, computers only do what we tell them to do. Okay, so defining variables. Moving right along, variables of the same type can be defined in separate statements like this, int length, int width, or in the same like this. And more commonly, you'll see it listed like this. Int length, comma width means both of these variables are the int data type. Variables of different types must be defined in separate statements. We just took a look at this in that other table, so I'm going to skip over this. This is just talking about the abbreviated variable definitions that we saw in previous page. Okay, to store an integer literal in a long memory location, put an L at the end of the number. Use an LL at the end to put an integer literal in a long memory location. I'd rarely see this in the wild, to be honest. Literals that begin with 0 are octal or base 8. Literals that begin with 0x are hexadecimal. This you do see. So if you're working with hexadecimal data, as we're going to see later on when we get to pointers, you're going to see when we print that data out to the screen, there's going to be a 0x in front of whatever comes next. Whenever you see that 0x, know that that means you're dealing with hexadecimal values. What do we got next? Hands-on, page 48. Just a sample program here illustrating how you can chain these together. So you can, I'm not going to type this one out, but you can see it here. Int floors equals 15, comma, rooms equals 300, comma, suites equals 30, semicolon. Oops. Here we go. Floating point data types. So finally we get to fractions or decimal types of data. Designed to hold real numbers such as 12.45 and -3.8 stored in a similar form to scientific notation. All of these numbers are signed, meaning positive or negative. They're available in different sizes, i.e. number of bytes, like the float, the double, and the long double. So a float is less than the size of a double, and a double is less than the size of a long double. So small to large here basically is what they're trying to say. So float, double, and long is kind of the ordering, small to large. Floating point literals can look like this. So a fixed point decimal notation, 31.4159 or something like this. You can also use the E notation, scientific notation. This is perfectly valid. If you were typing in a floating point literal like this, you would not get a compile error. 3.14159 E1, which means the same thing as this. It's like times 10 to the negative, well, this is a different example, but 6.25 times 10 to the negative fifth. That's how you could represent that. They're double by default. You can force them to a float or a long double by putting that F or that L at the end. Let's check out this example. Page 51. Cruising right along here. Yeah, let's do this. 2-11. Just to prove to you that we can type values like this and not have the compiler complain, float distance equals 1 point some number E8, or times 10 to the 8th. Double mass equals 1 point whatever, 2 point whatever, E30. And the example has some fancy, like the sun's distance, the sun's mass. I'm just going to print them out. See out distance. Let's see what it prints to the screen. Notice my code completion there helping me out, type in my variable name. See out the mass. Like so. Cool. Times 10 to the 8th times 10 to the 30th. All right, so this gets into some kind of weirdness when you're assigning different values of one type to another type, assigning floating point values to integer variables. If a floating point value, a literal or a variable, is assigned to an integer, the fractional part is truncated, in other words, chopped off and discarded. So if you have an integer called rainfall and assigned to it 3.88, that's not an integer. So what you're going to see is it's going to chop off the 0.88 and just display the number 3. You got to be careful with this kind of stuff, especially when you get into mathematical operations, particularly division. If you start dividing values of different type, dividing a float by an int or an int by a float or a double by a float, this gets into all kinds of strangeness when it comes to rounding of the decimal point. And it still confuses me to this day, so I have to be careful with it myself. All right, before we get there though with the math stuff, let's look at the char data type. Used to hold single characters or very small integer values. Usually occupies 1 byte, a numeric code representing the characters stored in memory. So if you have something like this, char, keyword char, here's your variable name, equals the character uppercase C, the variable letter holds the integer value 67. So where did that number come from? Like this random 67 thing, where did that number come from? That's something called the ASCII table. Let's find a nicely formatted one here. Not that one. How about this one? Maybe. How do I view the image? Here we go. All right, let's look for the letter C. Standard ASCII. So notice the columns here: decimal, hexadecimal, binary, octal, char. We're going to look in the char column for the letter C. And sure enough, if I go over here, decimal value is 67. You can see the hex value equivalent, the binary equivalent, the octal equivalent. So behind the scenes, when the computer sees the letter C, the char C, it's substituting the value 67. Here's a sample program. Illustrating a char. So we have char letter. Letter equals the character A. Notice the single quote. And when we print that out to the screen, we see a letter A. Same thing for the letter B. Remember, uppercase A is not the same as lowercase a. So there is a difference in the ASCII table. If you were to look up uppercase A, that would have a different numerical value than the lowercase a. Oops. Character literal, same thing. We can print out character literals instead of a string. Remember, strings are enclosed in double quotes. Character literals are enclosed in single quotes. Let's check out listing 213. This is kind of cool. Let's do this one. Sort of interesting and proving more or less what we were just talking about with the ASCII table substitution. So EX 2-13. Check this out. Char letter. Letter equals what looks like the integer 65. How can I assign an integer to a char? Well, because of the ASCII table stuff we were just talking about. Let's see out, if I could type. See out letter, see out endl. And let's say letter equals 66. See out letter now. Notice I didn't actually return a value here. Oop. I just said return. Just to show you that error, we'll return a number. We promised to return an integer, so we better return an integer. And here you can see that ASCII substitution. 65 for the letter uppercase A, 66 for the lower or uppercase B. A string literal. So shifting gears here, a string data type, we've seen strings before. They're a little bit more of a complex data type than a double or an int or a char. You store them as a series of characters in consecutive memory locations. So behind the scenes, we're storing each letter or each character of the string in a separate memory address. And by convention, it ends in a /0. It's called the null terminator. /0 automatically placed at the end. So this is what's called a character array. We'll talk about arrays in a later chapter, but it's a sequence of chars with a /0 by convention placed at the end. That's how the computer knows that we're at the end of our string when it sees that null terminator. So is it a character or a string literal? Well, you can tell by the quotes. Single quote, you're dealing with a char. Double quote, you're dealing with a string. Even if a single letter is enclosed in double quotes, it is still a string. It is not a character. The fact that there's only a single letter here doesn't mean that it's treated as a character. It is treated as a string. Because of what I just said about strings being a more complex data type, we do have to include string to create and use string objects. So we've used string literals so far. We've created like hello there and printed that out to the standard output. But if we want to create string objects like this, a string variable, we have to include the string package. We can assign values to string variables with the assignment operator and display them with cout like we are quite used to doing. Hands-on, page 58. And I want to do this one just to show you that additional include. Short-term memory loss, 2-15. And let's see what we're dealing with here. Okay. So I got my IO stream. I'm going to include string. Cool. That allows me to create string objects, movie title. Technically, it's a string object. It's not a string variable. Objects are like, you could think of them for now as like an object is a more complex sort of variable. Movie title equals Wheels of Fury. I don't know what that is. Mortal Kombat. Best movie of all time. The original. Should go watch it. Cout. My favorite movie is movie title. Like so. I'm going to show you the different way to run a project that's not configured as a startup. Remember, you can right-click the project, debug, start new instance. Same thing. My favorite movie is Mortal Kombat. All right. Bool represents values that are true or false. Bool values are stored as integers. They can be stored as a single bit, really. It could be stored as 0 or 1, represented by 0 being false or true by 1. Create it like this. Bool all done equals true. Bool finished equals false. All done contains the value 1. Finished contains 0. So the computer behind the scenes is not going to store true or false in the memory address. It's just going to store a 1 or a 0. Page 60. Here you go. We'll just take a look at it here. So bool value equals true. When we cout bool value, we see a 1, not true, not the text true. We see the integer 1. When we print out false, we see the integer 0. Okay, determining the size of the data type. So the size of operator gives the size and number of bytes of any data type or variable. Size of is a built-in C++ function. I think it's even a C function, but for sure C++ function that will tell us how big that data type is. Let's take a look at this hands-on. Page 61. 2-17. Include IOStream using name space std. I am not using my normal keyboard here. Should have warned you about that earlier. All right, double apple. Size of a short int is, here's that size of. Notice I don't need to really include anything to get this, but I just say size of, highlights in blue, followed by the data type, short. Bytes /n. I'm just going to copy and paste this. Size of a long size of an apple, which is a double. So here we'll say a long. Here we'll say size of apple. So that's not a data type. Apple is a double though. Nothing wrong with that. 217. Let's debug it. So a short int is 2 bytes, long int is 4. That apple, which is a double, is going to be 8 bytes. That may not seem particularly useful now, but later on when we get into dynamic memory allocation, we will need to tell the compiler in the running program how much memory to actually allocate at runtime. Here we go. Variable assignment versus initialization. We talked about this a little bit already. And I'm going to clean up one thing here. Here we go. So initializing a variable gives an initial value to a variable at the time it is defined. Some or all of the variables being defined can be initialized. So instead of saying int length, semicolon on one line, and then length equals 12 on another line, we can just combine that all into a single line. And this by far is what you'll see out in the real world in the wild. You'll see this combined in one line. So we declare it and we initialize all in a single line. And you can do some more shorthand this way. You can say int width equals 7. Implicitly, we know the height is going to be an int. It's all in the same line. Height equals 5, and then area is not defined. It's been declared, but not initialized yet. Let's talk a little bit about scope. Scope of variable is the part of the program where the variable may be used. Variable cannot be used before it is defined. So here's an example, int num equals 5, or num1. Cout num1 is fine. Then we cout num2, which is not fine. We have not declared and initialized num2 yet, so we cannot use it. Scope shows up all over in C++ programs. We're going to be talking about it throughout the entire semester, so just know that the scope basically defines where a variable can be used. Let's take a peek at page 64. Here's that same example. So cout value, then we declare and initialize the value. Can't do that. We will get a compile time error saying, hey, you did not declare the variable value, but you're trying to use it. Remember, programs are executed from top to bottom, line by line, one line at a time. So we're trying to output value before we have told the computer what value is. Okay, getting close. Arithmetic operators, math. How do you do math in C++? Well, the good news is it's not very hard. You're probably used to this if you've seen any other programming languages or if you've had a math class. Arithmetic operators is the fancy term used to perform numeric calculations. We have unary, binary, and ternary operators. Unary meaning 1, binary meaning 2, ternary meaning 3. I would say the binary operators are probably the ones you're most familiar with, comfortable with. The ternary one is probably the one that looks a little bit alien. Let's start with the simple ones though. Binary arithmetic operators. So we have addition with the plus sign. You can add numbers together with a plus sign. What more can I say? Subtraction, you use the minus sign. Multiplication uses the asterisk, sometimes called the star. If asterisk is hard to say, star. Or Shift 8 on your keyboard. Forward slash is division, or the question mark key on your keyboard. This is, I think, our first example of something that I'm not a huge fan of in C++, in that different, how should I say, the same character is used for different things. Okay, so division is a single forward slash, comments are 2 forward slashes. It's kind of similar. Modulus, if you've seen any other language, any other mainstream programming language has a modulus operator, basically returns the remainder of a division. So in this case, it's 7 divided by 3. 3 goes into 7 2 times with a remainder of 1. Modulus. All right, here's what I was talking about as far as dividing numbers and some of the confusion that surrounds that. If you're straight up dividing 2 integers, you're going to get what's called integer division. So 13 divided by 5 displays 2 because 5 goes into 13 twice. 2 divided by 4, in terms of integer division, you're going to get 0. 4 does not go into 2 any times. If either operand is floating point, the result is floating point. So the fact that you have a single floating point value in a division operation sort of converts the math to floating point. So 13 over 5, it'll show you 2.6. 2.0 over 4, you'll get a half. So notice here, maybe it would have been tempting to just put 2 divided by 4, but if you did that, you would get integer division, and you would not get 0.5. So make sure to include that decimal point 0 if you want to force floating point division. Modulus operator computes the remainder resulting from integer division, so 9 modulus 2. Displays 1, and this is interesting, requires integers for both operands. You cannot perform a modulus operator on floating point or double values. Page 66. Here's a bunch of math. If you'd like, you can work through this on your own, but basically is exactly what we just talked about as far as the computations. Same kind of thing here. Oops. I've always kind of skimmed over the math parts of different programming courses that I've taught. Hopefully it's pretty self-explanatory. Comments? Okay. Used to document parts of the program. Used for persons reading the source code of the program, indicate the purpose of the program, describe the use of variables, explains complex sections. There are religious wars fought over whether or not you should comment your code at all. Some people feel that, hey, if you're writing good code, your code should be so wonderfully written that you don't need comments to explain what it's doing. Like the code should basically speak for or comment for itself. I'm somewhere in between. I use comments like if they're necessary, and if they aren't, I don't use them. Single line comments we've seen will comment out a single line. So // comments out this whole line. You can also do something like this, where you use // comment, and it will just comment out the remainder of the line. So you could have like something meaningful over here, the statement itself, followed by a comment explaining what it does on that very same line. Here's a multi-line comment. /* ends with // can span multiple lines. So whatever is between the opening and closing will be treated by the compiler as a comment. You can also do this as a single line comment, though I'm not sure why you would. Let's see, page 69. call that an error. Okay, programming style refers to the visual arrangement of the source code, provides information to the reader about the organization of the program, includes alignment of matching curly braces and indentation and white space. Should be used consistently throughout the program. So we're talking about things like indentation, tabs versus two spaces. Again, religious wars are fought on this subject. Should use a full tab when you're indenting, or should use two spaces. Python programmers, they like the two spaces. Most C++ programmers seem to like the regular old tab. We're going to kind of take this for granted as we go throughout the course. As it comes up, I'll mention it, but we're not going to have assignment questions based on programming style. One of the things we've already discussed as far as style is the decision to use this sort of curly brace as opposed to this sort of curly brace. Again, just a matter of taste, matter of style. Two more quick hands-ons here. Listing two, oops, what page is that? It's page 70. Look at this. This is poor programming style, though I'm pretty sure it would be a valid C++ program. The compiler doesn't care that this is all on 5 lines of code. Compiler doesn't care at all. It's valid syntax to the compiler. But to a human, not so much. In fact, when the compiler parses this code, it probably condenses it down into something that resembles this, removing all the extra indentation and spaces that are really good for humans to read it, not so good for, or not necessary, I should say, for a computer. It is syntactically correct. It doesn't violate any rules of C++. It's hard to read. This is the same program written in a much clearer style. Final hands-on. Tying it all together. So we can do some fun ASCII programs, like making ASCII art with the C++ program. With just this little bit of C++ covered, you can print pictures using cout statements. Here's the code to make a simple smiley face. And I'll leave this to you to do as an exercise, not graded, but kind of fun nonetheless. You can do something similar to make other sorts of ASCII smiling faces. Cool. Okay, so that is chapter 2. As a reminder, let me collapse all these. Here's a quick button in your Solution Explorer. If you want to collapse everything that's expanded, you can use this guy. Collapse all. Notice we didn't do every example throughout the textbook or throughout the chapter. I didn't even do all of them that I had written down to do because some of them are just so similar. Hopefully that's okay with you guys. But when you go to do your assignment for chapter 2, you should use this solution file and just add your programs for your assignments to this solution. So if I'm looking on my assignment section here, I have released chapter 1's program, or chapter 2, I should say. Chapter 2's programming challenges. Sum of two numbers, sales tax, number of acres, diamond pattern, video game levels, energy drink consumption, and how much paint. So 1, 2, 3, 4, 5, 6, 7 questions. 10 points per question, meaning 70 points total. Remember, they should compile. If they don't compile, if your programs are riddled with syntax errors and I can't get them to run, I'm not going to waste my time trying to correct them. At least send me code that's compiling. You'll get a 0 if it doesn't compile. Okay, so what you should do again, create new projects for each of these programs. Once you get all of them done, go ahead and locate the folder that contains this solution. I'll show you a quick shortcut for that. If you right-click the solution, open folder in File Explorer. Here I'm inside the Chapter 2 folder. I'm going to go up one level. Here is where I would right-click Chapter 2, send to compressed zipped folder. As we saw last time, this isn't going to work because I have the solution file open in Visual Studio. But if I were to close this, this is what I would do. It would create that chapter2.zip, and that's what I would upload to Canvas. Okay, that concludes chapter 2. Hopefully that made some sense. Just a sort of a gentle introduction to some of the basic C++ syntax, basic programs, cout, data types, math. Next week, let's see what we're going to get into. Oops, here we go. Topic for next week looks like expressions and interactivities. So here we're going to introduce the cin object. Typecasting, named constants, enums, good stuff in the next chapter. So the next chapter will be actually getting input from a user. So far we've just been printing information to the user. Next we're going to be offering interaction, how to collect data or information from the user. But that is all for now. That's the end of chapter 2. Thank you so much for listening and have a great day.